So this is chapter 7 of Rustaceans, macros. If you haven't come across macros before, they are essentially just code that writes other code, an example of metaprogramming, and they are parsed as part of the abstract syntax tree. So that's something that makes them a bit different to, or very different to C-style macros. And that's something that we kind of talk a little bit about here. Yeah, we'll kind of try and dig into it a little bit, but that's kind of where the power comes from in Rust macros, is the point at which they're expanded. Because they're parsed as part of the abstract syntax tree, they can only appear in positions where they are explicitly supported. So these are things like adding in patterns, statements, expressions, items, and impl items. But they can't appear in like partway through items. So like they can't appear as match arms or struct fields, and they can't appear in identifiers. There are two types of macros, which we are ambitiously going to try and cover today. Declarative macros, which define new syntax in a higher level declarative way, and they're generally considered fairly lightweight. And then procedural macros, which can give you function-like macros, but also custom drives, custom attributes, and they operate on input tokens and generate output tokens. Kind of see examples of both of those, so if that doesn't mean anything to you, don't worry. We'll start with declarative macros because they are generally considered the simpler of the two. You will also interchangeably hear these called macros by example, or macro rules macros, or just macros. You define a pattern which is matched at compile time, and then you use that to expand generating more code. And they're declared using this macro rules macro. You mainly use declarative macros for like fairly obvious like mechanical replacements, like I put in this one thing, I want it to generate this much larger thing. And you can define them in the crate. So as you do with normal code, you can just define it in the crate. But the one exception is it has to be declared before it can be used. It's namespaced. You have to export it if you want to share it in other places within your own crate. But being able to define it in your crate is great, because having to create a separate crate just for your macro can be annoying if you're just doing something small. All of the macro rules macros take this form. So they have a name, and then a series of rules where each of these rules are of this form, like pattern and expansion. So Rust loves pattern matching, and that continues to be true in macros. And in this book, Jon calls them matchers as the pattern and transcribers as the expansion. So it's just another way of thinking about the same thing. One of the examples that Jon gives of where you would use these is writing repetitive tests. So the example he gives is like say you wanted to test every numerical type with some setting both on and off. Then instead of copy pasting this, but one with U8, one with U16, one with I8, one with I16, 32, 64, 128, you could reduce down that boilerplate by writing a macro. So then once you've written your macro, which I haven't shown you the code for yet, you'd be able to just write this. So you know that each of these is going to expand to these two tests, one with it true and one with it false. Well, not exactly these two. There'll be one for, these would both have the U8. What that macro might look like is something like this. So you say, I'm taking a type as some identifier, and then I'm going to generate these two tests, one with it set to true, one with it set to false. We're going to go through the syntax in a little bit more detail, because this is probably looking a bit strange if you haven't tried to write one of these before. But generally, it's kind of this kind of repeating pattern that in this case we're doing for each of these. And create a playground link, but probably don't need it. What's happening here is your pattern matching again. So this is the type here, and we're saying whatever matches this type is going to become our meta variable $t. Then we have this as, which is just raw text. It's just going to match text that says as, and then we have a second meta variable $name, which is some kind of identifier. Then we've got this syntax here, which I'll come on to later, but the idea is this allows it to repeat multiple times. The asterisk is just like, there's a very limited set of tokens that we'll come onto for how they work in terms of expanding. But these particular like meta variables tell you what type that kind of fragment is. So they can either be an item, a block, a statement, a pattern, an expression, or a type. And these are called capture types, or also sometimes called fragment specifiers. There seems to be a lot of names for the different parts of this, but they're kind of boil down to the same thing, is that only certain things will match this. So if you've said that this has to be a type, then it has to be a type. It has to be a valid Rust type. It can't just be a random piece of code. You might as well also have noticed this is not does not look like normal Rust syntax, kind of U8 as, U8 test. What would that do in regular Rust? So the contents of your macro, the kind of the tokens that you're passing to it, they have to be kind of valid Rust syntax, but they don't have to be valid Rust. So they're not, can't be completely random. You couldn't have like an open bracket and no close bracket. It has to be kind of parsable as a token tree, but it doesn't have to be valid Rust that would compile in isolation. So we only went through some of those fragment specifiers. There's also identifier, which we saw in the example earlier. You can also have paths, meta, which is the things that go inside of these attributes, and a token tree, which is like the broadest, I think, just some kind of token tree, some kind of tree of tokens. I would really recommend, if you're interested in declarative macros especially, the little book of Rust macros is great for declarative macros. It goes into a lot of detail and talks you through, some of the things, how these work under the hood. So you'll see that referenced on quite a few slides where I just like this, a lot of this is lifted from the little book of macros. So mentioned about the asterisks, but it didn't explain what it was. This means it'll match the pattern before it 0 or more times. So in this case, the pattern is this. So this was our like U8 as, and then the name. We could also have done question mark for 0 or 1 time, or we could have done a plus for 1 or more times. This comma delimiter we're using, but we could have had a different kind of delimiter. This is a valid delimiter, so is a semicolon. And the Rust doc for this in macros by example goes through how these kind of repetition stuff works really well. In terms of like what's happening here, you kind of want to get your head into like token space when it comes to macros rather than regular Rust space. So if you take some normal Rust code, like let x equal, and then a closure that returns 4, if you just look at the tokens, which are essentially just like splitting on white space, then you have let, which is a keyword, x, which is an identifier, equals, which is punctuation, pipe, punctuation, and then 4 is a literal. Once the compiler gets its hands on those tokens, it can turn it into a syntax tree and turn it into something that actually means something. So this is a statement whose pattern is the identifier x, and whose right-hand side expression, so this whole bit, is a closure that has an empty argument list because there's nothing between our two pipes, and a literal expression of the integer literal 4 as the body. And that's that's me lifting it out of the book. That's how Jon's kind of described it, as what you can think of as what's happened once you parse it into the abstract syntax tree. There is this site, I just realized I've only shared one window, so I'll just drop a link to that in the chat for kind of exploring abstract syntax trees, which is pretty nice. Actually, do you know what? I'm going to change my screen share. So taking this example here from the book, you can then take your function and you can click on bits of it and see, okay, what has this been parsed into? There's my identifier x. There's my pattern that we kind of mentioned. So this is the let token there. And you can kind of expand it and explore it, and just, this is less useful for writing declarative macros, but it is useful for writing declarative macros, but it's particularly useful for writing procedural macros where you really want to like build up that familiarity of what that tree looks like, because you're essentially going to be building your own, although with a lot of helpers that mean you don't have to handcraft the syntax tree, as we'll kind of come on to. So go back to 1 second. So going back to slides. What's kind of happening with the declarative macros is the compiler is going to start to construct the abstract syntax tree, but when it gets to a macro, it's just going to construct a token tree from the tokens contained within the macro, and it's not actually going to parse the full abstract syntax tree. So the parser is going to see the macro contents as a token tree, and then that's going to be replaced by a valid syntax tree later. So it's like a kind of multi-pass approach. And yeah, again, I'd recommend like the little book of macros if you want to get into a bit of detail about how that's kind of working. If you take like an example here, so lazy static is a macro. The contents here, at the point at which the kind of initial pass of constructing the AST is being done, it just sees a black box of like, there is something here. There is something that's going to go here. Please fill it in later. And that kind of allows you to do, have everything kind of happen in its own world, as we'll kind of come on to shortly. Once the declarative macro has been expanded, the thing that's produced has to be complete valid Rust. So it could be an expression, which is anything that's assignable, could be a statement, like let statements, could be an item, like a trait definition or an input block. So that's the classic thing you'll see less with, you do see it sometimes with declarative macros, but especially with procedural macros, you'll see a lot of them implementing traits for you. Or it could expand to create a new type or do some pattern matching. The Rusty dev guide is pretty good for this. So even if you don't want to do development on the Rust compiler, this is still, I'd say, a useful resource for certain more detailed topics like macro expansion. So it goes into like a really nice kind of description of like, this is what happens. This is how it goes. This is how it kind of goes through each of the steps. Because obviously for the compiler, that's kind of your bread and butter, very important. Often when you're talking about macros, you'll hear people talk about whether or not they're hygienic, which is, yeah, if you're not familiar with that concept, it's the idea, could this macro being expanded cause some accidental capture of identifiers where you're going to be changing behavior and not know? And with Rust macros, you only have access to things that have been explicitly passed in. So they're kind of considered fairly hygienic. There are other things that can still get you in trouble. So one thing to kind of, as a kind of a good example, is considering what happens with this block of code. So we've got this function main, we have let x equal mains x, and then we have this macro that expands to this. It expands to let x macros x print line x. And you might be familiar in the VS Code extension Rust Analyzer, you can do like expand macro at cursor. And if you did that, you would just see these two lines pasted in where this is going. So does anyone want to hazard a guess at what happens on what gets printed here in the print line statement where we're printing X? You don't have to if you don't want to. Okay, no one is guessing, so I will tell you a common assumption. So if you looked at the macro expansion especially, you would think, so one person's guessed macros, another person's guessed does not compile. So you would think that shadowing would kick in. One person has guessed correctly, but with a question mark, which makes you think they're not sure. So it's a slightly funny example because when you expand it, it looks like this X is quite reasonably going to shadow this X, but despite the fact that they have the same name, they're actually in different namespaces. So not kind of a regular namespace, but in terms of when the syntax tree is constructed, they're totally different X's. And that's because these macros are partially hygienic. They only have access to identifiers that get passed in. So this X was never passed in here. So this code, the X in here, cannot exist outside. The only identifiers that can exist outside are the identifiers that existed, that were passed in to the macro and were existing outside of it. They don't have to necessarily have been an identifier like with a assigned value before you passed it in, but you have to have passed it in and has an identifier. So there's no shadowing here because it doesn't, this X never like makes its way out. It's in its own context. That is not true for everything. It's true for variables, but it's not true for everything. So this is what it looks like if you do full macro expansion. Prints are quite ugly macro expansion, so apologies for that. But you can see the macro expansion absolutely looks like it's going to shadow. And that's why macro expansions are great, but also don't tell you the full picture. So you should be a little bit wary of making assumptions based on expanded macros. But yeah, this is what we were just talking about there. So it prints mains X because the X is just totally different. And yeah, when people talk about like that kind of namespacing of variables, that's the syntax context of the X, and that's how it's avoiding it. And yeah, lifetimes and types are two things that are not namespaced. So you have to be quite careful with creating types and creating lifetimes within your macros and dealing with lifetimes in general, because you don't get this nice behavior of, I say nice behavior, it's confusing when you first look at it, but it's really beneficial because what you don't want is for you to call a macro and then have some local variable in the macro suddenly hiding all the code you thought you were calling. You want macros to be fairly like self-explanatory and not have to do a macro expand to figure out what's happening. So it's much better when it's got that nice clean interface of like, if I haven't passed it in, it's not coming out. And yeah, as I mentioned, you can still use macros to define identifiers, but you have to pass them in. So in this case, the X here is an identifier, even though it's not like a valid identifier yet because it doesn't have a value. This identifier, so when I do the let $I here, that is this X, which has come from the syntax context of the calling code. So that's why you can use it. And that's why it still exists. And yeah, as mentioned, it's not fully hygienic, so you can still get name clashes. So in this example here, we have written a macro which just takes nothing and creates a function. If you do that, then this function is going to clash with it, and it's not going to compile. You don't end up with any runtime weirdness like you would with shadowing, where you might not notice until later, but you do get a compilation failure. So you have a shared namespace with the call site for types, modules, and functions, which is really useful because you often use macros to generate functions, to generate types, to throw in test modules and things like that. Yeah, you don't have a variable, so you lose this shadowing problem that can cause you a lot of headaches and confusion in other languages. It's particularly C, but C has many a problem with macros. If you're exporting your macros, if you want to share it beyond just your crate and your module, then you can use fully specified types like this. Jon recommends using core where possible rather than std, and that's so that it will keep working in a no std environment. So no std environments are like when people want to compile for like small devices that don't have very much on them, so they want to just use the absolute bare minimum set they can. As well as this kind of namespacing, you also have this $crate keyword, which every macro has access to. It's a meta variable. It allows you to reference the crate in which the macro is defined, and that's so that you can kind of separate what functions you're calling from what the caller might have defined it. So if you want to use this library, you want to make sure you're actually calling that library and not calling something that the call site has declared. And if the call site was renaming a library especially, then you can get into weird behavior where you think you're calling one thing but you're not. Okay, so that was a real whistle-stop tour of declarative macros. There's a longer talk on declarative macros that we did online, and the little book of macros is really great for kind of explaining them. But we're now on to procedural macros. So with procedural macros, they operate a little bit different. They're not working on pattern versus expansion, I think just in the parameters. The input of a procedural macro is a full token stream, and the output is a token stream. That token stream that you're outputting has to be valid Rust. It can be any valid Rust. You can choose to ignore the input token stream entirely if you want. Why you would do that, I don't know. But they're not necessarily hygienic, and they can increase your compilation time significantly, partly due to the fact Jon says the part of it is the sync rate, which you'll show in a second, which you will almost certainly use if you're writing procedural macros, but it will increase your compilation time. There are three types of procedural macros. You've got your function-like macros. So these look like macro rules macros when you call them. There's no way you would be able to necessarily tell which one you were calling. But what makes them a bit different is the actual things you can do with it. There's a lot more you can do with it. And that output token stream is going to replace the entire macro invocation. With derived macros, these are ones that you'll probably have, well, definitely have used if you've written any Rust, because you'll have implemented copy, you'll have implemented clone, you'll have probably implemented debug, and all of those are derived macros that create new items in addition to your item. So they read the contents of the thing you are kind of decorating, and then they create new items from it. So the token stream that they're getting in would be either a struct, an enum, or a union. You also have attribute macros. So these can be attached to items like struct, functions, traits. You probably have seen them on items within structs as well. And the return token stream is going to replace that item with an arbitrary number of items. So it could output the same thing and something else. Found this diagram. I didn't generate it. This is from the JetBrains blog, which I think is a really nice kind of description showing you where these token streams are coming from. In the case of a regular function-like macro, like ones like this, the body here is the contents that you're passing into the macro. In the case of a derive macro, so here we're doing derive bar, it's the contents below. So in this case, it's a struct S with all of its gubbins inside, and that's that token stream. And then with an attribute macro, you have two things. You have a first token stream, which is the attributes that could be passed in. You don't necessarily have to pass in attributes, but you typically do. And then the second token stream is some item. And that again, is going to output a token stream. In terms of when you use them, classic use is to automate the implementation of a trait. So I already mentioned these debug, clone, serialize is the other classic one. And the idea is that the implementation should be somewhat obvious to the caller. I wouldn't say like super obvious, but it should behave how you expect it to behave. You shouldn't use macros to do tricks because you'll give yourself a headache very quickly. So this was talking about derived type macros specifically. With function-like procedural macros, Jon recommends using these if the definition of your declarative macro is becoming too difficult. Difficular is not a word. Too difficult to maintain. So despite proc macros being more powerful and having a lot of access, as we'll kind of come onto in a bit, to additional functionality, they're actually not what people tend to reach for initially because of the hygiene that you get from declarative macros, the fact that you can define it in the same crate, the fact that they're kind of lighter weight. You generally want to use declarative macros first, and they're a lot that they're easy to write, but they can become very hard to read and maintain because that pattern matching syntax can get very long. You can have a lot of complicated matches. So if it's becoming too difficult to maintain, you want something that's a bit more manageable, you might end up switching for a proc macro. The other example he gives, which I have not heard of before, so example would be if you have a pure function which is executed at compile time and you're unable to represent it as a const function. And he gives this example of this crate PHF, perfect hashing function, which uses it for this exact reason. They also, it looks like, have a like a build gen, like script, which can do the same thing, well, a lot of the similar things. So that's the other way you could do it. But again, yeah, it's going to increase your compile time, but potentially for a much faster running code time. With attribute macros, classic example when you'd use these is for test generation, test setup. And yeah, and then framework annotations. So when you're passing in, when you're able to pass in argument functions, it means that you can add additional information that the framework's going to use. So in this example, if you've ever used Rocket, which is a service crate, and it's really easy to spin up a very quick service using these macros, then this attribute macro will generate a bunch of code behind the scenes that you don't need to see, that will take your function and generate a route from it that takes traffic at /world. You can also use attribute macros for things like transparent middleware. So the tracing crate is a very classic crate that's used for adding context and information to log messages, but also for sending out log messages beyond just the console to other places that you might want to gather metrics and whatnot for. And this instrument macro creates a span that has all of the parameters in your function. So then any tracing logs that you do, so like tracing info, tracing warn, tracing error, will contain the metadata from that span. So they'll contain your argument there. You also often use attribute macros for type transformers. Apparently, this is not something I've seen. The example that Jon gives in the book is this pin projection behavior, which is the idea if you're borrowing a field from an address-sensitive type, trying to do that in a consistent way. Went a little bit over my head. I would love someone to do a talk on it because I did not exactly understand it. Yeah, but that's the pin project, and they use these attributes for that. So just kind of recapping, this is what the token stream inputs, where the inputs were coming from, and kind of hold that in your head, because we're going to start looking a little bit more about what that token stream is. So a token stream itself is a sequence of token trees. A token tree could be a group, which is if it's surrounded by brackets. It could be an identifier, could be a single piece of punctuation, or a literal, like a character, a string, or a number. And as well as its data, each token has a span, which is used for error mapping to the correct line. So if you can see where that came from, you can get the span and then say, this is where I want this error to report. But it can also be used for other stuff like syntax context. If you take that token tree, so this is a function-like macro, and you expand it, you can see you've got an identifier in the form of foo. Then you've got this group here because it's surrounded by brackets. That group itself contains a token stream containing a literal piece of punctuation, another literal, and then finally we've got another identifier here. And again, that's from the JetBrains blog, which is a very nice like two-parter. I'd recommend it. When you're working with proc macros yourself, rather than dealing with just the raw syntax tree yourself, which we saw earlier in that AST expander, is quite significant. The syncrate will generate the IST for you, so you don't have to deal with the token tree directly. You can just parse the token stream that you get in straight into an AST from the syncrate. If you're wanting to generate the output token stream, one thing you can use for that is the token streams from Str implementation, and that allows you to create a new token stream that you could then append to an existing token stream. One thing I don't talk about in the slides, but you'll see everywhere when it's talking about macros, is the quote crate, which is really useful for being able to generate your new token stream. So I'd recommend looking at the docs for that. And again, it has a lot of the similar behavior to what you get with declarative macros, of being able to do like expansion with like mini regex of asterisk plus and question mark for repeating patterns. And it's really powerful. When you're working with proc macros, you'll sometimes get errors, and macro errors can be, some of them are really good, so really well established crates. The macro errors are often very clear, but the reason they're very clear is because the writers of those macros put a lot of effort in to make sure that the error is being reported in the correct place and that it contains all the context that you need to solve that problem. So you have this synparse error type in the syncrate, which is one way you can propagate up those errors. And you can use that as well to define you can use a span to define a scope for an identifier token to make it hygienic as well. So if you've set the span to be the call site, then that means it's not hygienic because it really exists in the calling code. Sometimes you want that, but so the example we gave earlier of like kind of creating variables, if the span of your identifier is the call site, well, yeah, then you can shadow at will because the syntax context is the same. If it's a mixed site, then it means that variables are namespaced like they are with declarative macros, whereas the same as declarative macros, types, modules, etc., are not going to be namespaced. Okay, I've rattled through this very quickly, but there's lots of other stuff to talk about. I want to talk a little bit about C macros, just as I said. So if people are coming from a C background, I had a little look at a classic Stack Overflow post about why pre-processor macros are evil, and just talk about what makes these issues less of an issue in Rust. And not that they're not an issue at all, but just less of an issue. So the first one is you cannot debug macros. I think still somewhat true. There's tooling around to make it easier, and Rust Analyzer makes it easy to expand, but we've already talked about how expanding does not always give you the kind of full picture. I think most people would agree that macros are harder to debug than regular code, which is why you don't reach for them as your first thing. You know, you should definitely try and utilize all of your generics, all of your traits kind of right from the off before you try and like use anything else before you use a macro. Especially if that macro is fairly complicated and involved, because debugging it's hard, often reading it is the best way. Second one is macro expansion can lead to strange side effects. The hygienicness, I think, helps, but with proc macros, you don't have all of those same hygienic guarantees. So choosing to make your macros hygienic is really recommended. Yeah, if you don't make them hygienic, then you could have strange side effects and you wouldn't necessarily notice them. Also, having access to $crate makes them a little bit less liable to strange side effects, and fully namespacing all of your types. Macros have no namespace, so if you have a macro that clashes with a name used elsewhere, you get macro replacements where you didn't want it, and this usually leads to strange error messages. I think, again, we've kind of talked about this, partially solved with variables, but not for functions. You can still get name clashes. So yeah, you want to be very choosy about if you're generating a function to make sure that you're not going to clash with a function on the call site. And then macros may affect things you don't realize. I want to show you like an example of something else in Rust that actually makes macros more manageable, because in this post, they give this example of square. So you have this macro. This is not an example of when you would actually write a macro, but this is the classic example they give. I want to square something, and I also want to increment it. And what that gives you is this, which means even though I've only passed in this variable twice, I'm not incrementing once, I'm actually incrementing twice. So the end result of that, it's going to load, is you end up with 2, because you end up with 1 times 2, which is, yeah, not what you were squaring, probably not what you meant. And is this a problem with the macro? Maybe, kind of, because you don't necessarily realize that this is just being treated as kind of a set of text that you're going to repeat twice. But I think kind of more than just a problem with the macro, it's kind of a problem with this kind of pre-increment. There's a lot of stuff happening in a very short number of lines, and you couldn't write this in Rust because you don't have that post increment operator. And if you tried to write it by writing x equals x plus 1, that doesn't return anything. So you couldn't then use that in your square function. So it's kind of fixed by virtue of the fact that you can't actually write the same code. You would have to do something much more explicit. And that's, yeah. When I first found out that like post increment was missing in Rust, I was like, good, that means people can stop talking about pre-increment versus post increment. But it has other benefits like this, which I kind of hadn't appreciated until I read this chapter. So the kind of TLDR of that is that there are these 3 types of macros. If you want to know if you're using a macro, look out for this syntax, look out for an exclamation mark. look out for the hash symbol, and look out for hash exclamation mark for kind of init attributes, and also look out for derive. Macro rules macros are more hygienic, but can become unwieldy as they grow. I didn't show an example of any. I probably should have done. Actually, the trace and create is a really good one, so maybe I'll pull up some examples of that in a second. When you look at the macro definitions for like info macros, they're very long. They're very, very long. They're very useful and they do a lot. So there's good reason for it, but you can see how they can become unwieldy, and it makes you want to write code rather than just pattern expansion, because then you could write less code, but that code is probably going to be harder to work with as well. Yeah, and procedural macros are extremely powerful, but easier to misuse, and that's because you don't have the same out-of-the-box guarantees about being hygienic, and you can just do a lot more because you can just output whatever you want in the token stream. I haven't kind of necessarily gone into the use cases, but classic one is if you want to just write some other languages code in your code, you can do that with proc macros. You can just put some code in there and be like, why don't you please parse this as this HTML and turn it into Rust for me? And it can do that provided the syntax is close enough that it doesn't violate any of Rust's conditions for just parsing the syntax. And yeah, you should always reach for generics before reaching for macros. So if you are not familiar with all of the kind of generics and stuff in Rust, definitely swat up on those before you start going for macros. The basic syntax of declarative macros is you have a macro capture, in this case it's a type. You can then use that in your substitutions. You can repeat them with this kind of like mini regex set. And you can also use different separators here, so you don't just have to use a comma. The comma is the classic. Yeah, and in terms of further reading, the proc macro workshop by David Tolnay is really good. That has I go through some of the examples of that in our procedural macros video. It's got a lot in it, but it's really nicely worked out to build up your understanding of writing procedural macros. And they're actually, yeah, I would say quite useful. It also gives project recommendations. Also the blog that this one's from Ferris Systems. It's yeah, again, it's got a lot of detail in there. It talks about the sync crate. I think it talks about the quote crate as well. Yeah, so didn't talk about it in this meetup, but we have done in other ones. The quote crate can make it really easy to output token streams and use input tokens as part of it as well. So in combination with the sync crate. So in this case, we're parsing the input using this parse macro input, and then we're taking that and using the quote crate to do something with it. There's also, Rustaceans is written by Jon Gjengset. He also does a lot of online YouTube videos. The Rust proc macros one is really good. Can't remember how long this one is. I think it's not too bad. I feel like it's maybe like 2.5 hours. No, 4 hours. It's a classic 4-hour one. Sorry, it's very long. But yeah, also very good. And because it's 4 hours, you have a lot more opportunity to go into a lot more detail and yeah, understand it a lot more. And then the JetBrains blog that I mentioned, which is where I got a lot of those pictures from, are very nice as well. So this goes into a lot of detail, kind of talk about the vector example of how you can, yeah, why the vec macro is useful, so you don't have variadic templates, all that kind of stuff is in there. So I'd recommend that. And then the little book of Rust macros, particularly for declarative macros. And if you're going to start with macros, start with declarative before you go for procedural, just because they're more hygienic. So I wouldn't say they're any easier to write. They're just different. They're maybe easier to write for complicated things. Yeah. And yeah, we've got previous meetup videos that I can share links to in the chat for declarative macros, procedural macros, and how to write procedural macros. But hopefully this was a decent whistle-stop tour of of chapter 7 of Rust for Rustaceans. We can now just do general chat if people want to. Yeah, say like what you thought of it, what you thought of the chapter, how you feel about macros in general. And yeah, if you don't want to unmute and talk, you can also type in the chat. And while people are pondering their many questions, I will pull up the trace and crate can show you one of the examples of a macro. I guess I only kind of mentioned briefly the fact that procedural macros have to exist in their own crate, but you'll often would find like, so this has like tracing macros in here. I'm not sure if this has the declarative macros in or just the procedural. Okay, it has the declarative as well. So some of them are like fairly small, but some of them are pretty involved. I can't think of the example right now. Tracing log. I'm sure I saw some really long ones, but now I can't find one. So you just have to take my word for it. Silence a good thing or a bad thing?
Ciara, thank you for the nice talk. I love macros because there was a question you did for the audience, right? Yeah, I always think like these declarative macros are so nice to come up with a small DSL, domain-specific language, just to make your life easier. But you may have to be a bit cautious because people don't like to learn a language in a language and so on. So it's just a statement here to get your opinion here.
I think definitely can be useful. Like the classic example for using macros that I think I did in the last presentation is you. I'm trying to find some examples to show you what that looks like. But Rust is great for a lot of stuff, but UI is not one of them. So one of the ways people have tried to make it better with UI is some UI frameworks that are built around macros. So essentially you write your UI code in macros and then it generates code behind that is hideous, but generates UI for you that's easier to structure.
Hi everyone.
Hiya.
Yeah, this is my first time here. I'm currently a student at USW, University of South Wales. This is I did not know there's like a community for Rust developer. When I saw it on the Meetup, I was like very excited and I joined. This is my first time here. Yeah, thanks for the presentation about macro. So I've not been using Rust in production, so I only use it as for my personal project and personal learning and on all. But I'm not really seeing the use case where I need to build a macro to use. So of course I use a SADI and all these serialization and these serialization macros. But I've not seen a use case that will make me implement my own macro for use. And there's a code base I went through, which is Hyperloop. No. It's not. It's Z. Does anybody know about Z? Z editor. Z editor. ZED.
I don't think I do.
Yeah,
That's
you can
nothing.
Google
Yeah.
Z.dev. Z. Let me like drop it in the chat. Is the editor written in Rust?
Oh,
Is
nice.
in
Okay.
Yeah, so there's this code base is an open source editor. So there was a point they used a declarative macro for interacting with the DB, basically for implementing some traits on each of the IDs of each of the structs. That's the only use case I've seen it being used in like in production like environment. I just want to ask like which other case do you find it like do you like always like have to like implement a macro to use aside from building like a crate or a library something like that? Because if you are building a library you mostly want to go with building a macro building with macro. Yeah.
Personally, I don't end up writing macros basically ever. Like very rarely do I have to write macros. I like understanding them and expanding existing macros and being able to read them. But I very
Okay.
rarely have to write them. So I will defer to anyone else if they end up writing more macros than I do.
Okay.
Yeah, I've written some for like test stuff,
Okay.
and implementing traits that I end up doing a lot of for different things. But I find most of the macros I want already exist, so I just use other people's.
Yeah. Interesting. Thanks for the response. Once again, it's nice being here.
No, welcome.
Mhm.
And you give a good example of like, yeah, writing libraries and reducing boilerplate. When you know other people are going to have to write the same code over and over again, and you could just generate it, then you can write a macro. But
Yeah, I went through Axum and then Sardi code base. I saw procedural macros, and the code are so big that it gave me a headache when I was going through it. For procedural macros, yeah, they make it so complex. Well, it's not complex, but it's doing this some beautiful things for us. But procedural macro can be very, very, very complex. Very, very, very complex. Yeah.
completely, they're doing the hard work, so we don't have
Yeah.
to like with so because
Yeah.
you could write that boilerplate for 30, but it just discourages use of the crate because then it's harder to use. So people end up doing horrible workarounds to avoid writing boilerplate. So the macros,
Okay.
save people from themselves and just be like, look, you can't be bothered to write the
Okay.
code, I'll just write it.
Yeah. Does anybody like write code production base here?
Write
Rust
macros
in
in
production?
production code base or just
No,
Rust
no,
in general.
like just general Rust in like production environment.
I do at the
Wow.
minute, yeah.
Wow, interesting. That must be a lot of fun. I only write Go for work, Golang. I'm dying to try out Rust in production.
You'll like it. It's yeah.
Yeah.
Especially I think it makes a lot of stuff easier. It's a bit it's yeah. It's
Mm,
easier to write than I thought it was going to be before I was using it in production. Like just learning about it, that you're kind of
okay.
learning all the details and you're getting focused on the code.
Yeah.
But when it comes to actually writing functional stuff, that like as in things that do the things you want it to do, a lot of the helpers and stuff you need are there, which is really nice.
Okay. I have this general question for everybody. Which is your personal favorite trait?
Favorite what, sorry?
Trait.
Trait.
Yeah. I have a personal favorite trait.
No, feel free to drop your favorite trait in the chat,
Okay, my
guys.
favorite trait is the iterator trait.
The what,
The
sorry?
iterator. The iterator and the double-ended iterator. Trait in Rust. Do you understand me at all?
Yeah, no, it's just
Does
the
anybody
specific
understand
trait
me?
you're saying that I'm not getting. Could you type the name in the chat? I think maybe I don't know it.
Yeah, iterator.
Oh, double-ended
Iterator.
iterate. Iterated. Yeah, yeah.
Yeah. Oh, sorry, I did not pronounce it well.
No, it's
The
fine.
iterator trait. Yeah, it makes me like perform like write code in a more functional way, and then reduces like lines of code I need to write. Yeah, that's why I just love to use it. I just, in fact, when as much as I try to implement the trait on my on a structure I want to use, to just to make like life easier. For example, like for Fibonacci, so you can, if you want to like implement like a if you want to like implement Fibonacci, you can declare a struct and implement an iterator over the struct, and then it makes everything very, 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 very easy for you. All you need to do is just run a loop till any point you want to do. Yeah, very, very interesting trait. Yeah. Yeah. Tim, do you have something to say about that? Which is your favorite?
So in the struct, you had like implemented some kind of like array memory of the Fibonacci numbers. How does it work?
Oh, the Fibonacci numbers.
More
So,
the implementation of the double-ended iterator. I'm curious.
okay, so for double-ended iterator, so basically the only thing it has to do, it allows you to do, is to basically call next back. So now if you have an iterator over a sequence of numbers from 1 to 10, do you understand? So if I call next, the first number will 1. If I call next on the function, it will be 2, 3. But if I call next back, it will give me 10 from the back. If I call next back again, it will give me 9. So now I called next till the point 2. So I have 2 to 8 left. Do you understand? So when I keep on calling the next, it won't, basically the next back will get consumed. We have like on iterators, we have like two types of method. The consumer, a method that can consume the iterator, and the method that can
Aggregators and consumers.
yes. So basically, the double-ended also provide a next method that consumes the iterator from the back. Yeah, that's like the difference between the iterator and the double-ended iterator. Yeah, I've not really had
I
a
see
use case for that.
you get away from the combinatorial explosion which you would have with recursion function calls, right? That's the idea.
Okay. Beautiful.
Yeah, I think iterators in general, like definitely coming from a C++ background, you end up, yeah, it's once you kind of detach yourself from your usual coding pattern styles, it's really nice getting to, work with iterators a lot more. Yeah, you tend to reach for them before you reach for anything else, which is nice.
Good. I've never written C++ before. I've never written C++. I come from a TypeScript background, from TypeScript. So yeah.
I like how many TypeScript developers there are. But like, I feel like Rust has a really like broad people who come
Yeah.
to the language, which I think has benefited it massively in terms of like
Yeah.
people have different expectations of what a language should provide and what it shouldn't. Whereas like you take a C programmer, they're like, no, don't give me anything. I don't need it. And then you take and actually once you have it, you love it. So it's good. But
Yeah.
other developers
Yeah.
kind of being like, no, people want these quality of life improvements, like a
Yeah. Very interesting. Very interesting. I love Rust. Everybody loves Rust. Yeah. By the way, you should try Go too. You'll probably like it too if you like Rust. Just hopefully. Just hopefully. Yeah. A lot of things are very similar. Very similar. Yeah.
all right. We are
That's all.
sorry.
That's all from me.
Thank you and
Yeah.
welcome. It's very great having new people. And one thing I would mention is we're looking for speakers again for future chapters. All the future chapters are up for grabs. So if anyone would consider doing one, even if it's your first time doing a talk, I'd recommend it. We're a small crew, so it's no pressure. It does get uploaded to YouTube after. That's the one kind of caveat. Alvin, go ahead. Also, nice to see you again.
Yeah, it's like if you want speakers, I would like to take either chapter 8 or 10 because like parallelism and like asynchronous programming goes one another. It's like basically the same thing, just like single core, multi-core, so on. I did a little bit of like async programming back in C#, but not as much in Rust so far. But it would be a good opportunity for me to learn more about it.
That would be great. Yeah, I'd say like async programming in Rust is slightly different, and that's kind of where the interesting bits are. So definitely, recommend the chapter, and that would be great. I'll message you and we can decide on a date after.